So we're going to look at 3 different ways that you can solve a system of equations. Today we're going to look at the first way, which is solving a system of equations by graphing. Okay, so how we're going to do that is we're basically going to make a picture and then we're going to find the point that makes both equations true. So how you do that, step 1 is you graph both equations, which we already know how to do. And then we're going to find the points where the lines intersect or cross each other. Okay, so intersect means the same thing as cross. If you're not going to remember that, you might want to add a little note to yourself that means cross. All right, now there are 2 special cases. Case number 1, if the lines don't cross each other. So find the point where the lines intersect, that's our solution. So where they cross each other is the solution. If they don't cross each other, then that means there is no solution. Okay, but if your 2 lines end up being the same line when you graph them, then what that tells you is that every point is a solution. Okay, and the way that we write that, we say no solution if there aren't any points that are solution. If all the points are the solution, then we say that that is an infinite number of solutions. Okay, so if they are the same line, then they're always crossing each other. So every point's a solution. So it's an infinite number of solutions. There we go. All right, so let's take a look at a couple of examples here. So this first guy, we're going to go ahead and graph. So remember, these are in slope-intercept form. So the number at the end is my y-intercept. So I'm starting my line at 2. And then the number in front of the x is my slope. So there's like an invisible 1 there. So it's like a 1 over 1. So from this point, I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, right? You want to make sure that you give yourself a lot of points because we're going to try to find the spot where the 2 lines cross each other, and the more points that you have, the easier that will be. Okay, then I'm going to draw my line. ID cards work great for making straight lines. There we go. So there's my first equation. Then I'm going to graph the second equation. Well, the second equation, the y-intercept's 2, so it starts here. And then my slope is -4. I'm going to put a 1 there, so it's a fraction. So I'm going to go down 4 and over 1. Down 4 over 1. Or I could go up 4 and over 1. And there's that line. There we go. Okay, so our solution is the point where they cross each other. Okay, so our solution for this particular one is going to be that point right there. That's where they cross each other. So just be really careful that when you write your solution, you write them in the right order. So remember, you run and then jump for points. So this guy, I ran to 0. So I ran 0 sideways, but I jumped up 2. So my point will be 0, 2. That's my solution. And there we go. That's it. Okay, so let's look at a second example. We're going to do the same thing. So my intercept here, my y-intercept is 3. My slope is -5 over 2. So I'm going to go down 5 and over 2. Down 5 and over 2. That one went a little bit off my graph, but that's okay. I'm not going to be able to fit a point in the other direction. And then I can draw my line. Don't forget arrows at the ends of your lines, of course. Okay, and my second one, this one starts at -4, so that starts down here. And my slope, there's an invisible 1 there, and we put out a 1 under it to make it a fraction, right? So I'm going to go up 1 and over 1, up 1 over 1. Well, I think we just found our solution. So I'm graphing that line. Nice and straight, arrows at the end. Okay, and again, our solution is the point where they cross each other. So our solution, right, is this point right here. So I would run to 2 and jump to -2. So my solution is the point 2, -2. And there we go. Okay, so that's the general idea of what you're doing. Now, we said that there were a couple of special cases, so I want to look at what those look like. Okay, so on the next page of your note packet, okay, there are examples of when you have 1 solution or 2 solutions or no solutions. Okay, so let's take a look at those. So this guy right here, this 1 solution one, let's start there. So the first one starts at -1. And then you go up 5 and over 4. That's my slope. So up 1, 2, 3, 4, 5. 1, 2, 3, 4. Or I could go down and this way 4. Okay, so there's my line. Ta-da. Okay, and then my other line starts at 3. So I'm going to put a point at 3. My slope is 1/4, so I'm going to go up 1 over 4. Or I could go down 1 and go the other way 4. And there's that line. Okay. All right, so this one has one solution because these lines only ever cross each other once. If you kind of envision what would happen if you made these lines longer, right? They keep going like that. This end's going to keep going that way. This one's going to keep going that way. They're never going to cross each other again, right? So this one only has one solution. Okay, so just like the ones we did on the front page, those only had one solution. This one's going to be this point right here. So that's run to 4, jump to 4. So that's the point 4, 4. That's my solution. So that's got one solution. They only cross each other once. All right, now as an example of one that has two solutions. So this is my system. This first one I already graphed for you. We're going to learn how to graph these later this year. Like one of the very last things that we do this year, we'll be learning how to graph those. So for right now, I don't expect you to be able to graph it. Okay, but we should be able to graph this second one. So y equals x. This one's a little bit tricky because our starting point is invisible, right? There's an invisible plus 0 there. So my starting point is going to be at 0. And then my slope, there's an invisible 1, so 1 over 1. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1 to make my line. Okay. And there we go. Okay, so again, I don't expect you to be able to graph this U-shaped thing. It's called a parabola. All right, but I would expect you to be able to look at this and tell me, oh, Miss King, there's two solutions, right? Because there's 2 points where these guys cross each other. So the solutions for this one of them is right there, good old 0, 0. The other one is right there. That's the point 1, 1. So this one has two solutions, 0, 0, and 1, 1. Okay, if you get some more complicated equations, you can sometimes have 3, 4, 5, lots of different solutions. All right, and then the last one are no solutions. Okay, so if there's no solution, so I'm going to graph these. So the first one starts at 4. My slope is 2, so 2 over 1. So from there, I'm going to go up 2 and over 1, or I can go the other way. There's my line. So I'll go ahead and draw that. Okay, and then we're going to do the other line. So this one starts at -3. Oops, sorry, that's the wrong color. Here we go. Starts at -3. My slope is 2 over 1. So I'm going to go up 2 and over 1, up 2 and over 1, up 2 and over 1. Okay, and then here's my line, and I'm going to draw this one in. Okay, so this one's a no solution. So if you take a look at these lines don't cross each other. And if you think about what's going to happen, right, these lines are just going to keep going the way they are. They're going to keep running like this next to each other, but never touching. So the fancy word for that, try to think, do you remember what the word for that is when two lines never cross each other? It starts with a P. Parallel. Okay, so those two lines are parallel. Okay, so they're never going to cross each other. So anytime you have two lines that are parallel, that means that you have no solution. Okay, the way that you can tell they're parallel, right, is because our slopes were the same. I kept going up and over by the same amount. That's what keeps them, right? That's what keeps them parallel. So when they have the same slope, that's going to be kind of your cue that you have a no solution. All right, now the one thing that I want you to be careful of, because this is a mistake that I see a lot. What I see a lot is I'll give somebody a problem, like I'll give them a system of equations, and then they will graph it wrong. So they'll have a graph that looks like this, and they'll graph their two lines, and one of them will go like this, And then another one will go like this. And they'll say, oh, they don't cross each other, so there's no solution. Okay, well, that's not true because these two lines would cross each other, right? If I made this go longer and I made this go longer, right, they cross each other out here outside of your graph. So that would be your solution. Okay, so what you need to be careful of is if you sometimes when you graph something, right, if it looks like you don't have a solution because it's off the graph, that doesn't mean no solution. Okay, so this would not be a no solution. This would be a hint that you should go back and double check your work because you probably messed something up. Okay, so the only time that it's no solution is if they're parallel. So it has to look like this. If it just looks like you can't see where they cross on your graph, that doesn't mean that there's no solution. It just means that you should go back and double check your work because you might have messed something up.